Okay, so question 6, given graphs f and g are sketched, points A and B are the x-intercepts of f, B and C are the x-intercepts of g, D is the turning point of g. Okay, so we see both these graphs are parabolas and both of them are happy face parabolas, which means that the A value of both these graphs will be positive. Okay, 6.1.1, write down the coordinates of E. Now E is the y-intercept of the f graph. The rule for the y-intercept is you make x equal 0. So for the f graph, wherever we see x, we're going to put 0. So y is equal to 0 squared minus 4. So y will equal to 0 minus 4, which is negative 4. So the coordinates of E will therefore be 0 and negative 4. 6.1.2, determine the coordinates of B. Now if we look at our graph, B is the x-intercept of the f graph. It's also the x-intercept of the g graph. The rule for x-intercept is you make y equal to 0. Now the only graph that we can use here is the f graph because we have the equation of the f graph. So in the f graph we'll make y equal to 0 and we'll solve for x. So 0 will equal to x squared minus 4. Factorize that, that's the difference of 2 squares, so 0 will equal to x plus 2 into x minus 2. Take each bracket, make that equal to 0. X plus 2 equals 0, so x equals negative 2, or x minus 2 equals 0, x equals to 2. Now if we look at the location of B on the graph, B is on the negative side of the x-axis. So our coordinates for B will be negative 2 and 0. 6.1.3, if the x value of D is negative 3.5, determine the coordinates of C. So we need to look at our graph to see where D is and where C is. So D is the turning point of the graph of G. The x value there of the turning point is the axis of symmetry of the graph of G. So the axis of symmetry will be x is equal to negative 3.5 there at D. The coordinates at B we worked out earlier was negative 2. So to go from B to the axis of symmetry there will be negative 2 going to negative 3.5. That's 1.5 units to the left. So to get C, because it's symmetrical, we need to go from the axis of symmetry 1.5 units to the left again to get C. So from negative 3.5, if we subtract another 1.5, we'll end up with negative 5. So the coordinates there at C should be negative 5 and 0. 6.1.4, determine the values of x for which g double prime x is greater than 0. Okay, so let's start with the equation of g that we have. We were given that g of x is equal to ax squared plus bx plus c. If we find the first derivative, we'll end up with g prime x is equal to 2ax plus bx. Now if we find the second derivative now, g double prime x will equal to 2a. Now remember, the graph of g from the diagram is a happy face graph, which means that that a value there in ax squared plus bx plus c is positive. So 2 times any positive value for a will be always a positive answer. The question wants us to determine values for x where the second derivative is greater than 0. Greater than 0 means positive. So this graph will always be positive. So x will be an element of all real numbers. 6.2 now. If we given the graph y is equal to a over x plus p plus q, this is your hyperbola. They gave us that the domain is x is the element of all real numbers, but x is not equal to 3. Now that x is not equal to 3 for the domain of a hyperbola is very important. It means that there's an asymptote there at x is equal to 3. They also gave us here that y is equal to x plus 5 is an axis of symmetry for this hyperbola. The function is increasing for all values of x except x is equal to 3, which we know is our asymptote. draw a sketch of this function. Right, when you're drawing a hyperbola, you need two asymptotes. One is your x is equal to something, and the other one is your y is equal to something. We already know that our one asymptote is x is equal to 3. To get our other asymptote, we're going to use that asymptote with the axis of symmetry. So into our axis of symmetry, we'll substitute x is equal to 3. We'll get y is equal to 3 plus 5. So our other asymptote will now be y is equal to 8. So whenever you draw a hyperbola, the first two things you draw in are your asymptotes. So we'll draw our vertical asymptote at x is equal to 3 and our horizontal asymptote at y is equal to 8. We must remember now that the function is increasing from left to right, so we'll draw our graph in the quadrants, the opposite quadrants as shown in the diagram. They're always increasing from left to right.